In the previous video, we had discussed about valency. We had discussed that valency is the number of electrons that are gained, lost, or shared to achieve stability, right? But did you think of where these electrons that are gained are coming from? Or if electrons are being lost, where do they actually go when they're lost? And what about electrons that are being shared? With whom are these electrons being shared? Well, turns out that every electron that is gained, lost, or shared takes part in chemical bonding. So, if one electron is gained, lost, or shared, one chemical bond is formed due to that. If two electrons are gained, lost, or shared, two chemical bonds are being formed due to that. Similarly for three electrons, right? So basically, the number of electrons that are gained, lost, or shared are equal to the number of chemical bonds being formed. So that basically means that we can say that valency is the number of chemical bonds being formed by an element, right? Remember, this really makes a lot of sense when we think of it in the light of how we started discussing valency. Valency was discussed as the combining capacity of an element, right? So to take that a step further, can I say that atoms combine for the sake of stability to form molecules? And we can extend that and say elements combine for the sake of stability to form compounds, right? Okay, now let's look at valency from the lens of the number of bonds being formed. Okay, so let me list out a few elements. Let's pick up a simple molecule, a simple compound, hydrochloric acid. The chemical formula is HCl. So we have one hydrogen atom and one chlorine atom. So the valency of hydrogen is 1. That means hydrogen is capable of forming one chemical bond. I'm denoting that with this dash here. What about chlorine? Chlorine also has a valency of 1, and so chlorine also is capable of forming one chemical bond, right? So hydrogen and chlorine can then bond together and form HCl. Now, while this animation is intuitive, what's happening actually in reality at the atomic level is a little more complicated than that smooth transition animation. Okay, but anyway, these dashes are a good way to imagine a bond for now. Okay, let's take another example. MgCl₂ will be our next example, magnesium chloride. Okay, where's magnesium? Magnesium is here. Magnesium has a valency of 2. It's capable of forming two chemical bonds, right? Okay, what about chlorine? Chlorine is capable of forming one chemical bond. Now, if you look at MgCl₂, you'll see that there are two chlorine atoms and one magnesium atom that are bonding together, right? So let's pick up two chlorine atoms. How do you think these two chlorine atoms would bond with this magnesium? Well, of course, it would be something like this, right? Great. Let's make some room for the next example. Our next example is water. Water's chemical formula is H2O. That means it has two hydrogen atoms and one oxygen atom, right? Okay, so hydrogen is up here. Hydrogen has a valency of 1, and we have oxygen here that has a valency of 2. Let's draw out all those things with those dashes. There you go. Okay, so we have one oxygen that's capable of forming two bonds and two hydrogens that are capable of forming one bond each. The story here is very similar to MgCl₂, so I'm sure you're going to follow. There you go. Okay, let's pick up something that's a little more different and maybe a little more complicated. Let's move on to CH4. That's methane. Methane is a greenhouse gas. Okay, I'll leave all that discussion for later. Let's focus on the bonding. So we have carbon here. Carbon has a valency of 4, and it is capable of forming 4 chemical bonds, right? Okay, now we have hydrogen. How many hydrogens are there in methane? In one molecule of methane, we have 4 hydrogens, right? So I've drawn all of them here. Now, how do you think these 4 hydrogens are going to bond with carbon? Well, they're going to take one spot each like that. So carbon forms 4 bonds with 4 atoms of hydrogen, right? Okay, now let's move to our last example, and this one is a little tricky, so I'd encourage you to pay attention. So this example is CO2, carbon dioxide. It has one atom of carbon and two atoms of oxygen. right? So carbon, as we know, has a valency of 4, so it's capable of forming 4 bonds. Let's move that to the center, okay? And oxygen has a valency of 2, so it's capable of forming 2 bonds, right? But we have 2 atoms of oxygen, remember, okay? Now I'll pause for a moment here and encourage you to try to predict how the bond between carbon and these 2 oxygens is going to be formed. Okay, I hope you got it. Let me explain it to you. So we have 2 oxygens, both are capable of forming 2 bonds. We have 1 carbon capable of forming 4 bonds, right? What if I drew these bond lines or these sticks like this? Could I do that? 2 on this side, 2 on this side, right? And what if I kind of drew the bond line sticks, as I like to call it, like this for oxygen? Now the oxygens can slide in snugly into the carbon and we get CO2, 1 carbon atom and 2 oxygen atoms. Okay, so to summarize, we can say that valency is the combining capacity of an element, and valency can be calculated in 2 ways. It can be calculated as the number of electrons gained, lost, or shared to achieve stability, or as the number of bonds formed by an element, right? And these numbers are actually equal, right? Okay, and we also saw that atoms combine to form molecules, elements combine to form compounds, and all of this is for the sake of stability. That's it for this video. Thanks for watching.